Okay, ladies and gentlemen, this is for series. This is the second part of a very, very short unit. And a series is nothing more than adding up sequences. So when you're counting sequences, all you're doing is adding as you go, and then it becomes a series. So that's kind of the big difference. So if I look at the problem here, section of an amphitheater can seat 18 people in the first row, and each row can seat 4 more people than the previous row. So the first row's got 18, second row's got 22, third row's got 26, fourth row has got 30, the last row has got 34. So the total number of people that can sit in the first 5 rows is going to be that. 18, 22, 26, 30, and 34. So you can use a calculator or you can do mental math. It's entirely up to you. So if I do 18 and 22, that's going to be 40, plus 26 is going to be 66, plus 30 plus 34 is, so the total number of people that can do that is going to be 130. So, story time, late 1700s. Karl Gauss was a student in a small German school. Gauss was a bit of a troublemaker, and the teacher was fed up, so as a punishment, he made Gauss sit in a corner, add up the first 100 integers with the thought of this being a very lengthy and tedious task. Gauss finished within seconds. Here's how he did it. Or how did he do it? So, well, here's all he did. He did this. Okay, and here's what this means. You take the sum of a n number of terms, take the number of terms divided by 2, add the first and the last. So when he said add up the first 100 integers, well, you know the first one was 100, the last one is 100. So 100 divided by 2 is going to be 50. So all I had to do was take 50 times 101. So 50 times 1 is 50. 50 times 100 is going to be 5,000. So his answer was just 5,050. And that was all there was to it. So that's how he did it. So that is one of 2 ways how to do the sequence of the sum of a arithmetic sequence, so which we call an arithmetic series. So let's take a look. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done each day by 1. He did a total of 1,085 push-ups for the month. How many push-ups did Aiden do on March 1st? So I'll tell you what, here's what I would do. I would use this first one for this, and this is going to be my sum, this 1,085. I know that my common difference is going to be 1. He went up by 1 every single day. And March has got 31 days. Yeah, March has got 31 days. So n is going to be 31. So my sum here is going to be 1,085. There's 31 days in March. I don't know the first term. That's what I'm trying to figure out. Plus 30 times 1. So I'll rewrite that down here. So here's what I got. 1085 equals 31 divided by 2. 2 times A1 plus 30. All right, so here's kind of what happens here. When I distribute this, I get 31 A1 plus 465, and that's still going to be equal to 1085. So now it's an algebra problem. So now 1085 minus 465 is 620. So I get 31A equals 620. So a little division, and A sub 1 equals 20. So on the first day, Aiden did 20 push-ups. So that's all I got to do for that one. So radio station is giving away a total of $124,000 in August. If they increase the amount given away each day by $100, how much should they give away on the first day? So again, since I don't know the last one, I'm going to do this. So I know the sum is 124,000. I do not know the first day, but I do know that there are 31 days in August. So 2 times A1 plus n minus 1 will be 30 times 100 bucks. So it's going to look like that. So now, much like we did before, we got a little distribution to do. So much like we did before, you're going to take 31 over 2 times 2a, which is 31a sub 1, plus this becomes 3,000 times 31 over 2, so 15.5 times 3,000 is going to be 46,500. So then subtract that. 124,000 minus 46,500 divided by 31. So a sub 1 is 2,500. So that first day they should give away 2,500 bucks. For this one, I'm going to use this second equation. Here's why. For one, it's really simple. It's way simpler than this one. It's not nearly as complicated. Two, I'm actually looking for a sum. I know that there are 90 positive odd integers between 1 and 180. I also know that the first positive odd integer is 1, and I know the last positive odd integer is 179. So anytime I know the first and last, I can do this, and that's what I want to do. So I want to take 180 times 40 or 90 divided by 2, which is 45. So the sum of that is going to be 8,100, and that's all there is to it. That one's pretty simple. So here, I still know first term, last term, and the sum, but what I don't know is what n is. So I can still kind of use that same idea. So the sum is 68. It's n divided by 2. The first term is negative 16. The last term is 33. So what I can do is figure out what that is and kind of go from there. So 68 equals n divided by 2. 16 and 33 is going to be 17 divided by 2. That's going to be 8.5. So if I take 68 divided by 8.5, so n is going to equal 8. So there's 8 terms from negative 16. That's the first term. 2, 3, 4, 5, 6, 7, 8 is 33. So now I kind of use that sequence part. How many common differences did I use? 1, 2, 3, 4, 5, 6, 7. So negative 16 plus 7 times my common difference will give me 33. This is back to the sequence part. So 33 plus 16 divided by 7. My common difference will be 7. So the first three terms will be negative 16, negative 9, and negative 2. There's my first three terms. There's a lot of pieces to that one. So evaluate this. All sigma means is kind of each number you put in for n. You put in for n from 1 to 10. So your first term will be 3 times 1. Second term will be 3 times 2. Third term will be 3 times 3. And you keep going up until 3 to the 10th. So which is kind of nice because I want to use this one for this because it's easy to figure out what my last term is. Okay, my first term is 3. The last term is 30. So the sum here is going to be 10 divided by 2, 3 plus 30. So it's going to be 33 times 5. So that should be 165 when I do that. So same kind of idea, except here going from 5 to 8. 5, 6, 7, 8. That's 4 terms total. So my first term here is actually going to be 14. 3 times 5 minus 1. 3 times 8 minus 1 will be the 8th term, or the last term. So that's going to be 23. So it's going to be 4 over 2. First term 14, last term 23. So that's going to be 2 times 37. So that's going to be 74 for an answer. So suppose you email a joke to 3 friends on Monday. Each of these friends send the joke on to 3 people on Tuesday. Each person sends and receives a joke on Tuesday, sends it to 3 more people on Wednesday. How many people have read it by Friday? So Monday, you got the joke plus 3 people. Tuesday, they send it to 3 more people. Okay, so 3, 3, 3. Wednesday, they send it to 3 more people. Thursday, they send it to 3 more people. Friday, they send it to 3 more people. So how many people have read it? Well, going to be 3 times 3 times 3 times 3 times 3. So that's 243. But remember, you also read the joke. So there's 244 people that have read the joke by Friday. So anytime you're doing this where you're multiplying over and over and over again, this is called a geometric series. So just like a sequence where you multiply over and over again, this is kind of what you do. So the sum of a geometric series where the first term is 1,000, the nth term is 125, and r is going to be 1/2. So I can do this kind of a couple different ways. Since they give me a to the n, I think I'll do it that way. So they give me 1,000 minus 125 times 1/2 all over 1 minus 1/2. Since they give me that nth term, I might as well use it. So 125 times 0.5. All right, 1,000 minus that. So that's 937.5 divided by 0.5. So the total sum of that, all multiplied together, is going to be 1875. So Maria arranges some rows of dominoes so that after she knocks over the first domino, each domino knocks over 2 more dominoes when it falls. If there are 10 rows, how many dominoes does Maria use? So here, my common ratio is going to be 2. I'm multiplying over and over and over again. N is going to be 10. It's kind of nice when it rhymes like that. And A sub 1 is going to be 1. So now, since I have this situation, I want to use this one. All right, I don't know how many are in the 10th row. I could figure it out, but I don't need to. So my first one is 1. 1 minus my common ratio is 2 to the 10th power all over 1 minus 2. So 2 to the 10th is a really big number, 1,024. 1 minus that is going to be negative 1,023 all over negative 1. So how many dominoes did I use? 1,023 dominoes. All I did was plug it in here and go. That's all I had to do. Still, contagious diseases spread very quickly. Suppose 5 people are ill during the first week, and each person who's ill spreads the disease to 4 people the next week. How many people are going to be affected by the illness after the 10th week? All right, so 5 people during the first week, 4 people at the end of the next week. So it's going on by 4. So everybody's multiplying by 4. So my common ratio here is by 4. All right, my first term here is going to be A1 is 5. I'm looking for the 10th week. So by the 10th week, first group of people is 5. 1 minus 4 to the 10th week all over 1 minus 4. So 1 minus 4 to the 10th, 1 minus 4 raised to the 10th power. 10th power is pretty big. Times 5. This becomes negative 5,000. Negative 5,242,875 all over negative 3. So 17,47625. Yeah, a little over 1 million people by the 10th week. So 5 people spread that epidemic to over 1 million in the span of 2.5 months. So when people are wondering how fast Ebola is spreading, there you go. That's all I got. Come talk to me with questions. Get this figured out. You will have a quiz coming soon over this stuff. Thank you for playing. Have a nice day.